All right, hi everyone. We're doing conjugates today, so let's go ahead and provide you some examples of what a conjugate would be. So before we said we worked this with imaginary numbers, now today we're going to work it with regular numbers, but specifically with square roots, because this is where conjugates come from. So if I say 3 plus the square root of 2, let's say this is one of my roots. What would be my other root? Because square roots always come in pairs. Now, why do they always come in pairs? Is because if I do quadratic formula on something, x equals to negative b plus and minus square root of b squared minus 4ac all over 2a. Do you see this plus minus here? We always end up with that plus and minus version. So if I gave you a 3 plus and minus square root of 2, that's where we get this plus and minus version from. So if I give you the plus one, we get the minus version also. It's always going to come in pairs. You're never going to get it one without a pair. It's like when you get Twinkies, you get, when you get Twix. You guys ever eat Twix candy? They always sell them in pairs, right? One for you, one for a friend. Now, the same thing happens if this was just, what if I give you just the square root of 2? The conjugate to this would have been negative square root of 2. Now we can see this from a simple example of x squared minus 2 is equal to 0. X squared minus 2 is equal to 0. If I plus 2 to both sides, x squared is equal to 2. Take the square root of both sides. Plus and minus. We end up with x equals to plus and minus square root of 2. They always come in pairs, and that's what I wanted to make sure you guys can see, is that if you have one, I can guarantee you also have the other. Okay, let's go ahead and continue this discussion. Now that we'll do both of these, we'll do these one first. We're going to go back and write the original polynomial now. So our polynomials work from our factors, x minus, and we're just going to copy that root in. I'm going to use a parentheses here so I don't mess up on my negative sign. So if you guys could do that next step for me by getting rid of that negative. And if you're ahead of me, you guys can go ahead and multiply those out. And see if you get the original equation, x squared minus 2. Okay, we have x minus square root of 2 times x plus square root of 2, because the negative and negative become a positive. And now you're going to go ahead and multiply these out. Lucky for us, all conjugate stuff cancels out. When I'm trying to get them back to the original polynomial, stuff always cancels out. X times x, of course, that's x squared. X times square root of 2. So I'm going to write that as x square root of 2, negative square root of 2, negative x square root of 2, and negative square root of 4. We're going to redo this, combine like terms. We have x squared minus the square root of 4. Square root of 4 is really 2. Okay, so you can see that using our given our roots as a square root, even though they gave us only one, we were able to derive what the second one is. Now let's do the same problem with the first example I gave you guys of 3 plus square root of 2 and 3 minus square root of 2. And let's take a look. So if I told you again, x is equal to 3 plus square root of 2, and 3 minus square root of 2 is something that you had to come up with, because they always come in pairs. They always come in pairs. Now, again can we write x minus 3 plus square root of 2. Make sure you write that parentheses as we start. Once you get really good at this, sure, you don't have to write the parentheses anymore, but I don't want to end up minusing points because you messed up because you forgot the parentheses. And then you forgot to distribute, and then your world became crap. Okay? Win-win. Now let's go ahead and just rewrite this. X minus 3 minus square root of 2, and x minus 3 plus square root of 2. All right, now here's the part that gets a little complicated, right? It's not super hard. It's just that you have to make sure you stay organized so you don't lose any numbers in the crossfire. We're going to multiply everyone by x, followed by negative 3, negative 3, negative 3, and then negative 2, negative 2, negative 2, negative square root of 2. Okay, here we go. X squared minus 3x plus x squared of 2. Multiply everyone by negative 3x plus 9. I'm going to give myself for a plus 9 because these are not like terms, right? And the last one is negative 3 squared of 2. And then we're going to go ahead and multiply everyone by square root of 2. Negative x squared of 2. Positive 3 square root of 2. And the last one is negative square root of 4. Now, I always ask you guys to do this step. What's a square root of 4? Isn't that just a 2? So I'm going to move this back over here as negative 2 to combine those like terms. Again, a square root of 4 is really just 2. Negative 2, that's a constant. We're going to bring it back with and mix it with a 9. All right, a couple things you want to notice is that these terms right here are automatically will cancel out. And hopefully when your last homework, you realize that a lot of these terms will cancel out. All right, so what do we have left? We have x squared minus 6x plus 7. Now, as you can see, I showed all the work here. I showed every step possible. In your test, if you don't show the work and you just jump from here to here, I mean, I don't believe I can do this all in my head. So you need to show the work. Okay. All right, that's it. That's how we got our original polynomial. Now from here, I'm going to go ahead and do this once to show you that if I do plug in any of these values, like 3 squared of 2, that this would go to 0. I don't know how it's going to work. It looks kind of messy, but let's go ahead and see if this would actually work. So if I plug in 3 plus square root of 2 squared minus 6 times 3 square root of 2, 3 plus square root of 2, plus 7, this looks like a gigantic, huge mess. But again, we're just practicing this to make sure this does fit in our brain. It does come out the way it's supposed to. We're going to multiply 3 plus square root of 2 times 3 plus square root of 2 by each other. If you remember squaring a binomial, you square the front, you square the back, and double the middle. That also works here. You square the front, you square the back, and we double the middle. It becomes 6 square root of 2. And this is what you would end up with. 3 times 3 is 9. 3 square root of 2, 3 square root of 2 gives you a 6 square root of 2. And square root of 2 times square root of 2 is really 4. We can simplify that. Square root of 2 is really a 2. So 2 plus 9 is 11 plus 6 square root of 2. All right, that's all the front. Let's distribute the middle term. Minus 18 minus 6 square root of 2. Then plus 7. We have positive 7 and positive 11 become positive 18. And doesn't 18 and minus 18 cancel out? Positive 6 square root of 2 minus 6 square root of 2. These cancel each other out, leaving me all with a 0 at the end. It worked. Now this skill of me plugging in a square root into my polynomial is not difficult, but it's something that you should practice so you can do it quickly. Okay. So the idea here is that if I give you one conjugate, so if I give you one root and it is a square root or imaginary, you can always come up with that second one. So let's do a rapid fire. I'm going to give you 3 quick questions and you tell me what the conjugates are going to be, okay? So tell me the conjugates. Tell me the conjugates. Okay, tell me the conjugates. So 1, 2, 3. First one is negative . Okay, tell me what the conjugates are. I'll give you guys another 20 seconds. All right, so hopefully you wrote the conjugate of negative 4 square root of 6 would be pretty easy, right? That's pretty easy. I'm going to go ahead and say that's going to be 4 square root of 6. On the second one, it's going to be 3 minus 4 square root of 2. Remember, the plus and minus goes to the square root, not the number in front. And that's from the quadratic formula. Same thing happens here on the right. It's still going to be negative 5 minus 4i. Now the next part I want you guys to do is go ahead and tell me what the factors, write the factors. So I want you guys to tell me what the factors are going to be. This is going to be a lot more writing, but it's okay. So I wrote it kind of a little small at the end there. Let me give myself more space. So you want to make sure you do write it with the parentheses. There's a thing where, sure, you might not need it because when you distribute the negative, it looks just like when you didn't. But if you didn't write the minus sign, it would have been the wrong answer already. So now if I redistribute it, it would be x minus 4 square root of 6, x plus 4 square root of 6. Okay. This over here would be x minus 3 plus 4 square root of 2, x minus 3 minus 4 square root of 2, x plus 5 plus 4i, x plus 5 minus 4i. Okay. And now if we go ahead and multiply them across, we can do that. And these are all the types of questions that we're going to be witnessing, we'll be seeing. This is going to be x squared. We know our middle terms are going to cancel out. That's going to be minus 16 square root of 36. Nicely for us, the square root of 36 becomes 6. 6 times 16 is 60 plus 36 is 96. X squared minus 96. Just to verify this, if I plugged in 4 square root of 6 into the problem, 4 square root of 6 squared, does that minus 96 become 0? 4 times 4 is 16. 16 times 6 is 96. Yep, that worked out. So that's my original polynomial. The middle term, if you multiply x, so instead of like whining, you just go ahead and do it minus 4x square root of 2. Our next term is going to be negative 3x plus 9. I write plus 9 over here. Plus 9. And then we're going to end up with a plus 12 square root of 2. And then we're going to multiply them by 4 square root of 2. 4 square root of 2 times x is positive 4 x square root of 2. End up with a negative 12 square root of 2. And negative 16 square root of 4. That's a 4 here. Okay, that's a 4. 16 square root of 4. Square root of 4 is 2. 2 times 16 is 32. We're really minusing a 32 here. Right. Combine them all down. X squared minus 6x. These two cancel out. These two cancel out. And we're left with a negative 23. Okay. How did I get 96? The way I got 96 here was when I multiplied, 4 times 4 is 16, and 6 times 6 is 36. 16 outside, 36 inside. The square root of 36 is 6, so 16 times 6. And 16 times 6 is 96. Okay. The imaginary on the right, x squared plus 5x minus 4xi multiplying by 5. Oops. Yeah, plus 5x plus 25. 5 and negative 20i multiplying by 4xi plus 20i minus 16i squared. 16i squared is really just positive 16. Careful. So I squared is negative 16, and negative is a positive 16. So again, remember, we're going to get rid of some stuff. These guys and these guys always seem to cancel out. X squared plus 10x. And this is going to be, looks like plus 41. So these are original polynomials. Now, one more thing here. I want to just make sure that this is true, just to double check. Let's use this. Is this factorable? Two numbers that multiply 23 that minus to 6. This is not factorable. 23 is a prime number. So if we do quadratic formula, x equals to negative b becomes positive 6 plus and minus square root of b squared, which is 36 minus 4ac. 4 times 1 times 23, 4 times a times c. That's going to be 80, 90, so minus 92, right? 80 plus 12 is 92. And we end up with a negative what? 86, 56. Yeah, 56, negative 56. Not 50, no. Ooh. So positive 56, positive 56. That was minus 4ac, right? That's a positive. Positive. All over 2a, which is 2. Square root of 56, I don't know what that is. 56 is 2 becomes 26. 2 becomes 13. Wait, that's not, that's 23. What? 28. 28. 2 becomes 14, and then 2 becomes 7. What? Messed up someplace. Let me check that again. I made a mistake here. It's not 90, it's not 56. When I changed the sign, I didn't fix it. That's 30 plus 90 is 120. 6 plus 2 is 8. 128. Sorry, 128. Yeah. 128. Let's take the square root of 128. It's 2, 64, and then we have 8 and 8. So it's 6 plus and minus 8 square root of 2 all over 2. We can divide the 6 and 8 by 2. And we end up with x is equal to 3 plus and minus 4 square root of 2. And that's back to our answer way up here. Right? 3 plus 4 square root of 2. So being able to go forward and backwards. Okay. Now we have one more skill here. What if they gave us a regular number along with our complex or along with our square roots? And that's something that we talked about before. But let's go ahead and look at an example of that. If I told you the root is 2 and let's say 3i. Let's say the root is 2 and 3i. Well, if you tell me 2 and 3i, that means I need to give you another one, another imaginary root to match. So you have to write the negative 3i yourself. So you need to include this one because our conjugates happen in pairs. Right? Our imaginary and our square roots always happen in pairs, in conjugate pairs. Okay, so we're going to write our problems to be x minus 2 because 2 minus 2 gives me my 0, x minus 3i, 3i minus 3i is my 0, and x plus 3i because the negative and the positive cancel out. Now, you could multiply this way, and that was 100% okay, but it's not the smart way. You want to get rid of the imaginary numbers or square roots first because you know that pair is going to cancel a lot of nice things. So I'm going to actually do it both ways. And let's do it the easy way first. Let's multiply these two together. That's going to be x squared minus 9i squared. How did I do it so quickly? Because I know the negative 3i and the positive 3ix will both cancel out, leaving me a no term in the middle. On the back, we have 3 times 3 is 9, I times I is I squared with a negative sign. This becomes x squared plus 9, right? So then we take x squared plus 9, and we multiply by x minus 2. And we go through our skills. X times x squared is x cubed plus 9x. 2 times negative 2 times x squared is negative 2x squared minus 18. Right? Negative 2x squared and then negative 18. Rewriting this, x cubed plus 9x, sorry, wrong order, minus 2x squared plus 9x minus 18. Now, what if you don't like yourself and you want to multiply it in this exact order? Would it give you the same answer? And you're probably saying, yes, Mr. Ko, but we don't need to see it. Well, I'm going to show you, and I'll do this fast. X times x is x squared. X times negative 3i is going to be negative 3i. I'll call it xi. xi. That's the other way. That's 3ix. 3ix. Meh. I don't have an opinion on that. Okay. And then multiply 2, negative 2x. These are not like terms. And 2 times negative 3i is positive 6i. Right? Now we're going to take this answer and multiply this by x plus 3i. That seems like a bigger mess, right? And it is a bigger mess. But it'll work. Believe me, believe. We're going to go x first. That's the easier pattern. X cubed minus 3ix squared minus 2x squared plus 6ix. Then multiply everyone by 3. 3i, 3i, 3i. 3i times x squared is positive 3i x squared. All right, those matched up. They're going to cancel out. 3 times the next term, 3, is negative 9 I squared, negative 9 I squared x. Because see, I don't have any I squares anywhere else. Okay, so that's a new term. Negative 3i times negative 2 is going to be a negative 6ix. Oops, let me get that in the same line. Negative 6ix, right? 3 times 2 is 6. I times x is just ix. Last one, 3 times 6 is 18. I squared. Now I'm going to change some of these values to make them a little more simpler. What is right here? What is right here? What does I squared become? That's really a negative 1. Negative negative is a positive 9x. We have a positive 9x here. And over here, this last term, negative 18. I squared becomes a minus 18. Okay? Those simplify down. So let's get rid of terms that cancel out. These guys go away. These guys go away. And we still end up with x cubed minus 2x squared plus 9x minus 18. And with the same answer. But with a lot more work, I feel. So you could do it. It would give you the same exact answer. But do you want to do it? Answer is no, you don't. You don't want to do that. Okay, the last part of today's work is matching graphs. And there's a couple of skills that we want to make sure, using the skills that we've learned already and the idea of end behavior, we could tell which way the graph is facing, which graph out of a set of graphs that we can choose would be the best guess, and with almost 99% certainty, we can guess it correctly. So let me go ahead and show you guys that in your homework today. Okay, this is our skill that we're trying to do. First things first, let's just take a look here. These are simple x squareds or parabolas. Okay, simple parabolas. So simple parabolas are pretty nice. But we're going to build off a skill quickly with what we see here. First thing, I want you guys to notice that that's x squared is positive. Let me just change color. X squared is positive. That's the biggest term you're looking at. And this is negative. So if it's x squared, let me ask you, if I square something, isn't a positive is positive and negative is still positive? So what happens is this graph, for sure, I know it's going to be up and up. Why? Because a positive and a positive eventually will always be positive. Now, which of these two choices here are positive and positive? Well, my only choice here. This is why x squared graphs always face up, because no matter what number you plug in, not maybe in the middle, not where the vertex is, but eventually this graph has to head up and up. Okay. Looking over here, take a look, that's a negative x squared. So this is a negative facing parabola. But why is that? Why can you always guarantee me it's negative facing? Because if x is a larger number, doesn't this graph go on to infinity in both ways? So what if I plug in 100 squared and negative 100 squared? Isn't this a huge positive number? This is a huge positive number also. These are both positive numbers. That means the graph should have gone up. But when I throw in a negative sign here, what's a negative 100 squared? That's going to be negative, right? Positive, 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 but the negative waiting for you on the outside makes your number negative. So the negative flips everyone around and gives you the opposite effect of what you thought. Okay, that seems like an easy one. You guys probably knew that one already. So negatives go negatives, positive goes positive. Sure, easy peasy. This next question is cubes. So I want to teach you this way of end behavior. And if you can learn it now, you don't have to learn in pre-calc because you know it already. So we don't care about any of this stuff right now to start. Just look at positive x cubed. On the right side, what's a positive times a positive times a positive? Isn't that positive? That means I can guarantee you that eventually this graph must be heading upward. Is this graph heading upward? It's not, right? So just by looking at the signs of a graph, you can make a decision which graph could this be. Yes, this is positive, positive, positive goes up. But what about on the left side? Is a negative times a negative times a negative? How come you use 3 negatives, Mr. Go? Because x cubed will give me 3 variables. X, x, x. And what if I told you these were all negative? Negative, negative, negative. Then they would stay negative. This would shoot down to negative infinity. On the right side here, I want you guys to ignore the rest. Ignore this all for now, okay? Ignore all that stuff for now. Looking just at the biggest bully here, negative 2 times x times x times x. All right? That negative sign is going to make a big deal for us. So on the right side, aren't all these numbers here positive? Isn't x positive? So what's a positive, positive, positive times a negative? Isn't this going to be a negative? And as you can see, as we go in the positive direction, this goes into the negative direction. What about on the left side? Aren't all these negatives, negative, and negative? But don't forget that negative 2. So what's a negative and negative? That's a positive. And that's why this graph shoots up in the positive direction. We also have a couple of tricks here. Find the y-intercept. You guys remember what the y-intercept is? It's at what point does your graph touch the y-axis here? And that hint from Algebra 1 is when x is 0. So if I plug in 0, 0, 0, which of these two graphs are going to shoot up to 125? Which of these graphs, when I plug in 0, 0, 0, zero, 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 isn't that just 0? Which of these graphs look like it would be 0 if I plugged in 0? As you can see on the right side, that would be 0. And this would be 125. Yeah, you know what? That eventually probably will get to 125. So we can easily see which graph goes where. So we said this one here, this one here. And we had like 2 reasons why that's true. Okay. Now, what if it's to the 4th power? Okay, an even exponent. So let's take this for example here. That's a negative 1, 2, 3, 4, okay? So you could plug in easy numbers here, but our goal is to not plug in easy numbers. We want to see what this graph will happen at a large x value. And aren't all x values here positive? Positive, 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 positive. Okay? Positive, 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 positive. But careful, there's a negative in the front. What's a positive, 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 positive become? Is positive times a negative becomes negative. I can automatically tell you this graph is going to be this guy over here. But what about on the left side? What's a negative times a negative times a negative times a negative times a negative? What I'm doing, I'm saying this is x to the fourth with a negative in front. Is it negative, 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 negative? That's positive. Positive times negative stays negative. Look at the left, that also goes negative. One more hint to this. What's the y-intercept of the problem? 0, 0, 0. What's the only number left? Negative 3. Take it out, negative 3. That's my y-intercept. Once you get used to the pattern, you can see that x to the fourth on the right side, positive, 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 positive will stay positive. That's why this graph goes to the right on top. Negative, 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 negative. This is also positive, isn't it? That's why the left side goes up also. And our y-intercept, 0, 0, 0, 0. 256, we're never going to hit 256, but we're on our way. So we can use these characteristics of these graphs, these polynomials, without really doing much work to match our polynomials. Now, this last section here, they're going to give you the regular problem and also the factored version. Okay, regular problem and factored version. And so we could use our previous skills. And let's go ahead and do that. You tell me which graph is which. Just looking at the exponents. Okay, let's do this skill first. Just looking at the exponents. Negative, positive, positive on the right, that's going to be negative. And negative, negative, negative on the left, this is going to be negative also, right? Okay, so sure, that's good. Easy peasy. On the right, x to the fourth, positive, 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 positive on the right is positive. Good job. Negative, 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 negative. That's 4 negatives. That's still positive on the left. Okay, good job. We know which one is which. But I want to show you this next part of this graph. What are the roots of this negative x squared graph? The roots are at 3 and 4. You guys agree with that, 3 and 4? And if you look at this graph here, the roots are at 3 and 4. That's another way for us to tell which graph is which and characteristics of us graphing a large order polynomial. Looking at the next graph, negative 4, negative 2, and negative 1. Are you guys okay with these are the roots of this graph? And take a look. This happens twice, a multiplicity of 2. So something special is going to happen at 2 and negative 2. So our graph we said was negative 4, bam, that was a root. With negative 1 was a root. And more importantly, something happened at negative 2. It didn't cross, did it? It bounced. And there's actually a trick. And the trick is, if you end up with a multiplicity that's even, you bounce off your root. Whenever you have a root that happens an even number of times, you don't cross over like we did here. We end up bouncing. And that's for a different discussion later. Okay. All right. I would say that's it. The next questions, the type of questions they gave you, they gave you like 4 different options. You're going to have to tell which goes where, hopefully using the skills that we've developed. And then they're going to give you also the same idea, except they're going to give you the factored ones, factored values, so you can match those a lot easier. Right? That's it.